Is there any extra credit if you finish both apt objectives? Yeah, it's outlined in the syllabus. So throughout the semester, if you want an A, you have to complete 2 expansion objectives. The expansion objectives can be completing extra homework assignments. So if you complete 2 extra homework assignments, your expansions are done. Or you can do any one of the expansion objectives. Like Physics Engine has an outright expansion objective. If you complete that, that satisfies one of those 2. If you complete that and both homework assignments, then you get both of them done right at the first learning objective, and you can be done with it. But yeah, you do get extra credit up to 2. You can't overload. You can't do all of the assignments for like the first 4 learning objectives and then skip learning objective 5. For example, there are caps, but that's outlined in the syllabus. Refresh your memory on that and give it a look. If you have questions about the wording, let me know. Make sure you get your questions answered early before you do extra work that doesn't count for credit. All right, let's. I thought I was starting our stream early. I ended up starting a minute late anyway. Okay, model of execution. Let's talk about this some more. We introduced stack and heap last time. Now I want to go through some examples, or possibly just one example, if that's the case, of seeing the implications of specifically the heap today. The second example talks about the stack a bit more. If we don't get to that example, I'm fine with that. If we just go real slow through one example and really start winding down the pace of this course, because this example really reinforces a lot, possibly even all of the content that we've seen so far, with some exceptions, I suppose. So if we go a little bit slower through it, and then push the second example that I have in these slides off till Friday, I'd be fine with that. Friday is all examples and just reinforcing the content, so I'd be perfectly okay if that happens. But I really want this first example. It's probably the most important example. It's probably the most important example that we've seen so far, possibly throughout the course. One example that you really want to pay attention to. It's going to help you throughout the whole course. Anyway, without further ado, here's the lecture question for today. Don't let the amount of text scare you on this. There's a lot of text here, but a decent amount of this text is me explaining some of the things that I have written here. So I don't just have the problem statement here. There are some extra notes, for example, here, a few different things. This question did confuse quite a bit of students last time, so I changed a few things just to make sure everybody's clear on things. I am having a good day, bro code dude. I'm having a good day today. Plus, I really like this lecture. The example's nice. I actually made a brand new example for this lecture just because it's so important. I wanted to get all the things that I need. So anyway, the lecture question today, in a package named execution, just like the last lecture question or two, create a Scala class named team and a Scala object named referee. We're going to have multiple teams, some undefined sport that these teams are going to play, some undefined sports teams as a class because there can be many different teams, and then one referee as an object because there's going to be one referee that can officiate games between any 2 teams. Teams are going to have constructors that take in their offense and defense as integer values, and then these are stored and then used later on in the program. Now, my note here, this needs to be said, this needs to be clear. Whenever I don't, and I've mentioned this before, but it needs to be repeated because this is a big trap. Can feel like that at least. These variables do not have defined names according to the question. So since they don't have names defined in the question, you cannot access these variables in your testing. So they represent the team's offense and defense, but I didn't put offense and defense in quotes. I didn't say name them offense and defense. So I can name them whatever I want. You can name them whatever you want. So if in my code, say I name them team offense and you name them just offense, if you access them in your test suite and you call them offense and you say team.offense, when that test suite is ran against my code and I use team offense for the name, it's going to crash because there's no variable named offense. So you can't access these variables in your testing. And that's by design because I want you testing without accessing them directly. And same with score. It's going to have a third state variable that represents the score of the team. It's initialized to 0 and it's a variable, and that's going to be set by the referee when a game happens. The labs are going to be the lab tomorrow. It's all day tomorrow, midnight to 10 p.m., like we say in the syllabus. And it's going to follow that structure. You have 2 hours from the start. You can start at any time in that time frame, but you have 2 hours to complete it. You do have to do it in that 2-hour window. And then an object named referee with a method named play game that takes 2 team objects as parameters. So after teams are created using this class, 2 team objects of type team are created. This play game method is going to take 2 teams, return nothing, but change the state variable representing the score of those teams equal to each team's offense minus the other team's defense. No negative scores allowed, so if the other team's defense is higher than the offense, their score should be 0. And then finally, a declare winner method, again, takes 2 teams, compares their scores only, doesn't look at their offense and defense, compares their scores, and returns a reference to the team that has the higher score. If it's a tie, create a new team and return that team with any offense and defense and score that you want. Just some team that's not one of the 2 inputs just to represent that neither of the 2 teams have won. And then finally, the test package. This last line is always the most unassuming but the most difficult part of these assignments as we're getting used to unit testing, is a test suite named test teams that's going to test all of this functionality. Now, since you can't access offense, defense, or score, you can't access any of those variables representing those values directly, the only way you can test this is by using the referee, calling play game between 2 objects, calling declare winner, and making sure declare winner returns the team that you expect to have won that game. So that's the only thing you can do to test all this functionality. Nothing else can be accessed because I might name things differently. And of course, I made up some really silly names to represent offense, defense, and score just to make sure that you don't accidentally have the same variable names as I do. So with that lecture question, let's talk about things. And a lot of this is testing your understanding of references. And the example we'll go through today talks about, you guessed it, references all throughout. So let's talk about a few examples. If we only get to multiple objects on the heap, that's fine for today. I'll go nice and slow. I'll watch chat. We'll digest this nice and slow and kind of play catch up today and Friday. I know the pace of this course is intense. There are designed slowdowns in the course, and this is the first one. It may not feel like too much of a slowdown, especially if you're behind, but this is where you can have a chance to get a little bit caught up. At least that's how it's designed. I'm sure you'll let me know if it doesn't actually work out that way. During lab, are we going to answer materials from the slides or just pure coding? It's pure coding, so just a heads up on tomorrow's lab. It's going to be a pre-homework. It's in the... Did I update the... Yeah, it's right here. It's a pre-homework for program execution. So it's designed to get you started on the program execution homework assignments. So if you want to prepare for lab, those of you stressing out, if you're worried about what the lab is, pick which of the 2 assignments you want to work on, read through that document, and make sure you have a good idea of what's going on with it. That's the best thing you can do to prepare for this lab. Next week's lab is a learning objective verification. For that, it's this week and last week's material. Be up to speed on everything. You're going to have an interview and a Thursday lab. Both. And I'll talk about that as we get closer because it's more pertinent. So let's start with this example. This is the example we're going to look through. We're going to go nice and slow through this one. Slow enough so hopefully everybody can see what's going on through this examples. No interviews this week, unless you have a makeup interview if you missed last week's interview. If you already finished... All right, I got to ignore chat for a second. If you already finished it, it's fine. The lab's designed to be somewhat independent of the assignment itself. It's highly related, but there will be more work for you to do tomorrow. But it's fine if you already finished. So let's look at this example. We're going to have a very simplified snippet of an RPG where we have characters who are gaining experience points. So we have a main method. We're going to create characters, create a party, etc., and have them win battles where they're going to gain experience. And we can have either characters winning single battles on their own as a lone adventurer, or we can have a party of 2 characters who can win battles as they fight together and gain experience. So give you a second. I'll look at chat and just absorb what this code is doing. You should be able to, at this point, follow through this code and know what is going to happen, what the state of variables are, and what the code is doing. But we're going to go through this very slow and see exactly what's happening in memory as this program executes, as this main method executes every line of code, as it jumps around to these 2 classes that are defined, as it calls the constructors, as it calls these 2 methods. This method, which is not in one of the 2 classes, if you look in the repo, this example is in the repo as well. There's an object called main RPG, I believe, that just contains these 2 methods. I just stripped out some of the extra code just so it can fit better on the slide. For the verification, do we have you don't have to have all the lecture questions done before the verification interview or lab, but that's probably your best way to study anyway. So I highly recommend that you do them. If you go into either the interview or the lab without having all lecture questions done, or at the very least knowing how to do them, maybe you just didn't go through the motions of actually completing them, you're probably going to fail the lab and the interview. If you don't know how to do the lecture questions, you pretty much have no chance on the other stuff. The lecture questions are supposed to be your easy lead-in into understanding the learning objective. And you have to do them anyway. Like, you have to finish those lecture questions anyway. Or at least be able to, and prove that by finishing the homework. But anyway, you got to do them. Why not do them right away? By the way, most of the class is really far behind on lecture questions already. It's a slippery slope. Don't fall into that trap. I really don't want to fail half the class because y'all got behind and just didn't keep up on the work. And if you're asking me if by next week, if you have to have the lecture questions done, yeah, you should have them done. That you've had so much time. These lecture questions are designed to be done day of the lecture. I actually used to have lecture questions due at the end of lecture. Granted, the lecture questions were a little smaller, a little more digestible when they were due at the end of lecture. But they're lecture questions. They're designed for you to do during lecture, at least the original design. I've extended the deadline since then, but they used to be the first time I used them. Sounds like a fun game. Yeah, parties are limited to 2 people. This is very simplified. I mean, this wouldn't actually be part of a game. This would have to be way more fleshed out. But I need the example to be small enough that it fits on a slide and small enough that I can get through it in a lecture and explain everything. There's not many office hours. There's fewer office hours this semester, but you should have been contacted by a TA of the course who will schedule additional time with you. Office hours tend to get flooded when they're open for the whole class. So I am having TAs reach out individually to students, and each one of those TAs has about 15 students that they are reaching out to. So they have time where they're focused on just 15 students. I always have this complaint that nobody, there's certain office hours where everyone goes to. If they're at like 5 p.m., 6 p.m., that's when everybody goes to office hours. So I'm trying to mitigate that. But that TA who reached out to you sent you an email and said, "Hi, I'm TA so-and-so. Do you need extra help? Are you struggling or whatever?" Contact that TA especially if the office hours don't line up well for you. That's evil. Did I say something evil? I might have. I have no idea how testing in Autolab works. We can talk about that after the lecture and that bonus time and go through that again. Or watch last Wednesday's lecture. I talked about it quite a bit. I solved the lecture question. I solved two lecture questions in class. An upsetting amount of the class. Last I checked, it was 60 students. Still haven't even finished those ones. Questions are way too hard. Some complaining. Where's the dog? I'm I mean, the lecture questions are pretty tough, but I'll go back to you should be spending 12 hours per week on this class. We're 2.5 weeks in. Have you spent 30 hours on this course so far? That's the expectation. Yeah, no joke. 10 hours plus this week so far. I mean, that's not outrageously against expectation. But 30 hours you should have already spent on this course. If you haven't spent 30 hours and you're complaining that it's too much work, you haven't done the work that's expected of you yet. If you spent 30 hours and you're still struggling and then come to office hours, talk to me, especially my office hours tomorrow. Let's talk about it. All right, so let's go through enough of that. You've seen enough. You've been able to look over this code enough. Let's see exactly what happens when we go through this example. So let's talk about this code. We're going to fill up this slide with all kinds of memory. So we start the program. We're going to start at the main method. At the beginning of the main method, right when the program starts up, we're going to ask the OS and the JVM for some memory for the stack. We're going to create the stack memory as a first in, last out data structure. So we can only remove from the top of the stack or the bottom because we're going to draw it from the top down. And we can only add to the bottom, and we can only remove the bottom element. So it's a stack data structure. That's where all of the variables are going to go that are not on the heap. And we'll see another example of the heap as soon as we create our first class. So any variables that are what we call primitive types, or that will compile down to primitive types in Java bytecode, are going to go on the stack. We'll see exceptions of that as soon as we create a class. If they're part of a class, they will actually go on the heap. I've seen confusion with that in the past, so I'll make that clear in this example. But when we have these two primitives, ints, doubles, characters, are all going to go on the stack. And we're going to pretend that strings also go on the stack. They don't actually, but we won't talk about that until we talk about functional programming and immutability. Strings are what we call immutable, and they have some fairly complex behavior, similar to lists. So let's put these two values on the stack. We're going to create two values, a mob XP when we defeat a regular mob. Our characters are going to get 20 experience points. When we defeat a boss, we're going to get 100 experience points. We're going to store those values in integer variables and give them names, add them to the stack. Mob was created first, that goes on the stack. Then boss XP was created, that goes on the next spot on the stack. And then the next value we create has to go right here. That's the only place that we can put it on the stack. The lab tomorrow's code, you have to do it in the 2 hours, but it's code. I mean, y'all don't have to stress too much about tomorrow's lab. It's not meant to crush you. It's meant to be the first lab where you're really doing something. All right, so we get to the next line. This is where we're going to ask the JVM or the operating system. We actually ask the JVM, and the JVM goes to the operating system, but the JVM talks to the operating system right at program start and allocates heap space. We don't have to be worried about the details. I hate that. About sums it up, Crunkle. I hate doing stuff. I don't want to do something. Don't make me do stuff. If you are working hard, you are putting in, you have 30 hours in so far, and you're struggling and you're a few lecture questions behind, make sure you talk to me. Make sure you talk to your TAs, and we'll do everything we can to help you out. Sometimes I'm harsh in lecture when I say things like this, but that's because I'm assuming you're working 1 hour a week and then saying, this is too hard, I don't feel like it. Those are the students I'm hard on. But if you're really working at it and you're just not getting it, but you did get the 115 material and you're studied up on all that, if you're in that situation, please talk to us. I really want to help you out. So we're going to ask the JVM and the OS for some heap space. It's going to give us some heap space. We're creating a new, whenever we see the keyword new, we're asking for heap space to store a new object. That object is going to go on the heap. So we're asking for a new player party character. This is going to call the constructor, which has no parameters in it. And and it's going to create an object of this type and allocate space on the heap for all of its state variables. Once the constructor is called, all of the code that's not in any methods is going to be executed. So the party character object is created, a variable named battles1 of type int assigned to 0 is created and attached to that object, and then a variable named experience points of type int is assigned to 0 is created again along with that object. So this object that we created of type party character, which was created using the class, which is a template to create objects, that was created, space was allocated on the heap for it, and we have this new party character on the heap with its own copies of battles1 and experience points, which would be separate from all other objects of type party character. And these values can change independently of other party characters. So this party character, we're going to get the reference. We're going to get the reference of where this object was created on the heap. That's what new returns. New party character or new any constructor, what this returns isn't necessarily the object that was created. It's not a copy of anything. It's a reference to the object on the heap that was created. So this heap created at some number I made up. These numbers are kind of meaningless. They're just different from each other when we have things on the heap. But this number at 428 is going to tell our program where to go to find this party character in heap space. So this new party character returns at 428 some reference which says where to find this on the heap. Where on my RAM stick was this party character created? Where on my RAM stick were these two variables created a lot that are associated with that object? Where? It's at 428 in this example, and that is what we store in the hero value. And that's what goes on the stack. We create a new variable named hero of type party character, which we can think of that as a party character reference. It never actually stores a party character, but it stores a reference to a party character. P, didn't you talk about pointers last lecture? They're similar to pointers. There's subtle differences, but it's very similar to pointers. If you think of them like that, I'm not going to get mad at you. But Ethan might next semester in 220 when the difference between pointers and references comes into play. So you can think of this as pointers. I'll call them references if you want to mix the two for now. In 220, when you work with C and there are pointers and references both, then you'll have to get the distinction down. So we have a variable named hero of type party character reference, a reference to a party character, and it only stores the reference of where that object can be found in heap space. So in heap, we have some spot somewhere on our RAM stick. We don't care where, but we know that we have a reference. This is going to return the location on RAM of where I can find that object that was created. That's what's stored in the hero variable here, or the hero value here. That's the only thing that's stored in that value. Yeah, there we go, P. If you know the difference, why are you asking about it each time? Or did you just cut and paste that from a Google search? I can't even focus on this lecture, still thinking about the last LQ I didn't complete. Yeah, try to take Toadfish's advice. Check us out in office hours. I have office hours tomorrow, 7 to 8:30 p.m. Eastern time. Come check me out. Go check out the TAs. Respond to your TA who reached out to you in your email. If you didn't even respond to them, then, I mean, what are you doing? And hopefully you did spend enough time on the lecture question as well. Too many people, so you never get a chance to see anybody. Yeah, so reach out to the TA who reached out to you in email. That's going to be your best bet. That's why that exists. That's why we're doing that this semester. Whatever TA emailed you, and if no TAs emailed you, send me an email and say, yo, my TA, and I'll look up who it was supposed to be, and I'll yell at them. But I believe all the TAs sent out those emails and contacted you. Send them an email back and say, yeah, I need help. Can we schedule a time to meet, or whatever they offered. That's going to be a better bet than office hours this semester. I pulled resources away from office hours this semester to have those individual TAs reach out to you and see how you're doing in the class. And they'll keep reaching out throughout the semester, by the way. They're in a sense responsible for you throughout the semester, at least for reaching out when you fall behind and things like that. So please take advantage of that. If you are struggling, let them know first. That would be your first line of defense when you're attacking this course, or when this course is attacking you, as it were. So this value stores a reference to the object that was created on the heap. Hopefully everyone's okay with that, or at least most of us. Everyone except Highlighted Wolf, I guess. Not to pick you on you, but when do the heaps get destroyed? The heap, so we won't talk about this in depth, but there is something called garbage collection in Scala. Heap objects get destroyed when you no longer have a value or a variable on the stack that stores a reference to that heap object. So if hero were destroyed, were removed from the stack, like if this were in a separate code block, hero was destroyed from the stack, then since we no longer have a reference to this object, the garbage collector is going to come in at some point in time and destroy that heap object and free up that memory. But we don't talk about that in this class. We don't need to go that far into things. In 220, you'll really get into that. C does not have garbage collection, so you have to collect your own garbage, which can get interesting. Not necessarily, Pug Guy Kev. So if we have multiple variables that have a reference to the same object, all of those variables would have to be removed from the stack in order to destroy that heap object. You actually won't ever be affected by that, because if you don't have a value or a variable with a reference, storing a reference to that heap object, you no longer have any way of accessing it. So you won't even know that it got destroyed, because you have no way of accessing it anyway. And that's why the garbage collector can safely do that, because your program no longer has access to it. It's going to destroy it. It's going to clean it up after you. Yeah, it cleans up. Next semester you have to clean up after yourself, and it gets tricky. Okay, so we hit our first method here. This method is not part of one of our classes. This is more of the style of method that we've been writing so far in this class in a lot of the lecture questions. This method is going to take two parameters, a party character and an int, representing a character and the XP that they're going to gain. And this is going to be called once they win a battle. So our hero was created. We sent our hero out to fight. Our hero encountered a mob, defeated him, won a battle, and is about to gain 20 experience for winning that battle. So we're calling win battle. We're going to put a new stack frame on the stack to begin this method call. We're going to add all the parameters to the stack with their associated argument values. So character of type party character, we're going to add that to the stack and assign it the first argument, which was hero. Hero is storing a reference to the object at 428. So we're going to assign that the reference to the object 428, not a copy of the object, not the object itself, just a reference. We're going to tell win battle, we're going to say, yo, this is where you can find a party character somewhere on the heap. We don't really care where it is, where on RAM it is, but we're going to say this is where you can find the character that I'm concerned about. And then give it the int. We've passed ints to methods all the time. We're going to also give it the int, add that to the stack, name XP value 20. That is a copy of the value because it's a primitive. It is going to be a copy of the value stored in mob XP. So the difference between primitives and objects there. Objects pass by reference. Primitives pass by value. It actually gives the value of that to the parameter, to the method. Then we're going to run that method, run the code inside this block. We're going to do character dot battles1. What that means is we're going to go to the character reference, which is at 428. The dot operator means go to follow this reference and follow it to its location in heap space. When you get there, access, so after the dot, that dot is very meaningful. After you get there, look for a variable named battles1, which we're going to find right here. Add and increment it by 1. Reassign it itself plus 1. We're also going to go to character dot, which means follow the reference, experience points, and add XP to that. XP resolves to 20 in this stack frame. I should have named one of these just plain old XP to show the difference of multiple variables with the same name, but that's what the next example is for anyway. And increment that by XP, which is 20. So we actually followed that reference, which we got from Hero originally, followed that reference and modified the values in heap space, in heap memory. This method ends. The stack frame is destroyed. It returned unit, so it didn't return anything. Yet it did affect the state of the memory of the program. So even though the stack is identical both before and after this method call, the values on the heap have changed. So now Hero, which refers to the same object, Hero actually did change. So after this method call, from our perspective, from our programming perspective, this method actually changed the values in Hero. That Hero actually gained experience and it tracked that battle 1. Because this passed by reference. We gave this a reference. We gave this a reference to Hero, not a copy of it, nothing else. It just said, hey, win battle, this is where you can find a party character in memory. Since Hero has that same reference, that same location in memory, Hero sees those changes. And this is the critical point, the critical part of pass by reference and references and objects being passed by reference, is that even a method that returns unit or any method that takes an object, if it modifies the state of that object, those modifications are reflected in the outer scope, outside of that stack frame. So we can affect the state of the heap across stack frames. And I thought I had it there. So it's on a different slide, but this is what we call a method that has side effects. So we didn't call this method for its return value. We actually called it for its side effects, which is modifying this character, this party character, in heap space, actually modifying that memory. We're not calling this method ever for its return value because it doesn't return anything. We called it for its side effect. So if you heard that term side effect, that's what they're referring to. So I'll get to that when I get to that line. I don't want to get too far ahead. It's the next line, but we'll talk about that. Chat slowed down, so I don't know if I lost you there. If we got to stare at this a little bit. We will call win battle 2 more times. So if you are lost on that one, keep trying to scroll down thinking chat's broken. But all right. Let's move on to this next line. This one's a doozy. We're going to do a lot on this line. I almost broke this into 2 slides. Looking at it now, I probably should have. It's making more sense now? All right, flip-flops. That's what I like to hear. You understand how win battle works? Sweet. Okay, so now let's talk about what Ellipso is asking about. So on this line, and whenever we have an assignment here, we're going to resolve the right-hand side of the assignment to a value first before we create the value and then the assignment to that value. So let's start on the right-hand side. We're going to call new party, but just like in math, we do what's inside the parentheses first. So we're going to start inside these parentheses, resolve each one of these arguments to a value, and then call the constructor to party. So let's do this in the order that the compiler, the interpreter is going to do it in. We're going to resolve hero to a value. Hero is just at 428. So hero is that reference at 428, the reference to this location in heap space. Next, new party character. We're going to call the constructor like we did when we created the party character that we stored in the value hero. We're going to create new party character. Nothing for the constructor. Give it its own variables, battles won, and experience points, and add that to the heap. Whenever we say new, we're asking for new heap space for a new object of a particular type. So we create a new object of type party character. It gets its own heap space. Again, the numbers I just made them up. The point is, we don't care where these values are in heap space. They can be anywhere on our RAM sticks, but we have some reference to know where to find them when we need them. This party character has its own copies of battles won and experience points. Whenever you create a new object using a class, they get their own copies of all of the state variables. So this party character's battles won and experience points will change independently of this other character's battles won and experience points. Told fish out. Okay, see ya. You don't have to announce that. So we're allocating space and the heap for this new character, but we never did store a reference of this party character on the stack. We never stored it inside the scope of the main method, so we actually can't access this party character again from the main method directly, but we will see that we can access it. I mean, spoilers, if you just look down here, we will access it through the party object. So after we have that object created, we're going to create a new party. A party does have constructor parameters, and we're going to give this its two parameters, and you can split, if you haven't seen this before, you can split parameter lists across lines. I did it just so it fits better on the slide, but if you have a long list of parameters, you can always split them up like this. This is the same thing as if I had these both on the same line and kept extending this. So this takes two parameters, two characters, two objects of type party character, or object references rather, of type party character. And I'm just going to name them character 1 and character 2. I'm going to declare them as values because I don't expect them ever to change. And I'm going to give them hero, a reference to hero, which resolves to at 428, and a reference to the new party character that I created. New returns the reference 272 in this case. So the party is going to get the arguments hero 428 and new party character at 272. Those are going to be the values of character 1 and character 2. So when I allocate space on the heap for this party, which is going to be at another made-up number, 596, I'm going to assign those state variables, character 1 and character 2, to the values at 428 and at 272, the values that the arguments resolved to. Once the constructor resolves, once the arguments are assigned to the parameters and these variables are allocated, or created and declared and assigned, then we're going to run all of the code outside of all of the methods. In our case here, we're going to create a variable named battles1 of type int and assign it the value 0. So those three state variables are attached to this object of type party and can change independently of everything else on the heap, even if we had multiple parties. Yeah, you can access the party characters independently, or you can do it through the party. You can do it either way, and that's why I have these three method calls down here to show that we can access them either way. So we have three values, three objects on the heap. We have references to them. Two of those references we can access directly from the main method, and one of them we can only access through the party reference. We can go from the party reference follow that reference, find it in the heap, find it in memory, access its character 2 variable, find that reference, and follow it to character 2, and then access its values from there, its variables from there. One note on, if you're doing rhyming dictionary, one note on everything outside the methods is called when you create an object of this type. This is where you're going, you can do anything there. You can call methods here. You can write any code, any valid code here outside of all the methods, and that will get run when you first create that objects of this type. So in your rhyming dictionary, that's where you're going to want to parse the dictionary. I recommend parsing in a method and then calling that method outside of all your other methods. Say var dictionary of type map of string to list of strings is what I used, equals parse dictionary of dictionary file name. If that doesn't make sense to you, if you haven't read that assignment, or if you're doing physics engine, you can ignore that for now, but just make a note of that. Anything outside of all the methods is going to be executed when you create an object of that type, and that's the only time you have access to the dictionary file name in the rhyming dictionary homework. So that's where you'd want to do that, where you'd want to parse that dictionary. Dropping hints. Oh, yeah. Do it small, you know it. Lab is called program execution. Probably going to consist of unit tests and classes and objects. Yeah, good call. For this week's lab, the program execution pre-homework is going to be writing some unit tests for the homeworks and getting started on your testing. We're going to introduce test-driven development, where we write the tests before we actually write the code, which can help you write the code. Next week for program execution, it's going to be a lot of stack and heap. I'm going to give you a program like this and ask you to walk me through what happens on the stack and heap. And you're going to have to do just what I'm doing in this example, walk through everything that happens in the stack and heap. That's what you can expect on lab next week. Then the interview is going to be talk to me about program execution. And the TA is going to drill you with some questions and make sure that you understand all the concept of all of the 2 weeks that we're covering here. How do I do Calc 2? Not my job. All right, so we did a lot on this line. Hopefully everyone's okay here. Different ways to... Some of it's preference, some of it's the way you want to structure your code to keep things organized. It depends what you want to... Oh, for a new party character, why didn't I store this in a variable? I think that was what you were referring to, actually. It's somewhat preference, but if I know I'm not going to use a reference from on the stack, like if I said val character, yeah, that's what you were saying, right? If I said val character 2 equals new party character, and then said new party of hero character 2, you could do that as well. But if I know I'm not going to use that value, that reference, in this method, then sometimes I'll just shortcut it here just to cut down one line of code. It makes the code look a little cleaner. And if I don't need it anyway, why store it? It's mostly preference. I did it in this example. I did it both ways in this example just to show you the difference in what's happening on the heap and stack when you do things a little differently. That's why I purposely did it both ways here. All right, let's get on to this next line. We're going to call party.winBattle of boss XP. So our hero and this nameless second character went into battle with the boss. They defeated the boss. They're both going to gain 1 experience point and also increase their battles 1 by 1. And also the party is going to increase its battles 1 by 1. So that's what's going to go on in this code. The big thing to focus on here is this keyword this. This keyword just blows minds. And don't get me wrong, it blew my mind when I first saw it too. We've seen it a few times. Hopefully this example solidifies your understanding of it. But this is a reference to the calling object. I've said that before. You've heard me say it. And hopefully this example, seeing it all spread out like this and all annotated, makes it a little more clear what I mean by that. The calling object is... Did I say calling character? The calling object stores a reference to the calling object. So party is calling .winBattle. Party, find the party, dot operator, follow its reference, and then call the method from here. And this, since it's an object of type party, it knows what its win battle method is supposed to do. It's going to go to the class and know how to call that method. When this reference is followed, this is saying, that's what I mean by saying the calling object. Party is the calling object. We're following that reference and then calling win battle from that object. So this object is calling that method. And yeah, it's the same as self from Python. It's calling this object. So, or calling that win battle method from this object. This is the calling object. So since party is the calling object, party, that at 596, the object calling this method through the dot operator or the access operator, that's what's going to be stored in the keyword this. So when we create this stack frame for the class party.winBattle method, since it was called from this object, this is going to store a reference to that calling object. So whenever I say this dot, that would be the same as if I was in the main method and said party dot. So if I said this dot win battle right here, which I shouldn't do because it'd be infinite recursion, it'd be the same thing as when I said party dot win battle here. Because party at 596, this at 596, reference to the calling object. Is there a place to find more examples? I do have an old example. If I won't show it in lecture because there won't be time. But I do have an old example after the lecture question comes up again. You can look through that one. The code for that one is also in the repo. Beyond that, I would just recommend Google. Give me class, object, stack, heap, memory examples. Get all those keywords in there. You should get some good examples. For practice, not just pre-written code explained. I mean, that's what lecture questions are. And I get complaints about lecture questions. I could have more. But the practice is the lecture questions. Lecture questions, especially today's and Fridays. They're written in a way where the references are moving around all your methods, and your testing has to make sure you're keeping track of those references. So it's not necessarily practice directly on stack and heap like this, but it is testing your understanding of the stack and heap, specifically the heap, to make sure that you're following those references properly. As for examples like this, the bonus example, it's the bird box example in the repo. If you start at bird box main, if you want some practice, try to go through this program and trace through the stack and heap. That would be excellent practice for the lab next week, if that's what you're asking. If you want practice with that, that's one that you can do. Yeah, Bird Box and Netflix. I used it 2 semesters ago when it was relevant. And then I used it again last semester, and the reference is pretty outdated. And then I was looking at it again this semester. I'm like, I can't use it again. That's a year old. So I switched the example to this one. Plus, I didn't really like that example. It was okay, but it had some problems. All right, so now when we access this, we go to this at 596.battles1, increment by 1. This, follow the reference, .character 1, follow the reference again, .battles1, increment, it was 1 because the hero already won this battle, increment it to 2. Do the same thing with character 2. Follow the references, increment that value, and then do the same thing for their experience points. Increment both of their experience points by 100. So this is a reference to the calling object. We can follow that reference. We can follow any references it stores and access any of the information that we need by following reference after reference as much as we need. We also have battles 1 and experience points. All these, I wanted to mention this earlier, but worth mentioning now. These are all of type int, except character 1 and character 2. And I said ints always go on the stack unless they're part of an object. So when an object goes on the heap, all of its state variables also go on the heap, even if they're primitive types. But when we create primitive values and we're not inside an object, they're going to go on the stack with their values instead of on the stack with their references to the heap. Then we're going to call party.winBattle again, just like we did with the hero. Oops, wrong one. We just finished that one. And this is my slide that I wanted. We call that method for its side effects. It returns unit, but it affects a lot of values in heap space. It goes to the heap, it changes things, it changes the state of the memory of the program quite heavily, even though it returns unit. So we never call that for its return value. And then we can call win battle like we did. We're a minute over, so I'll just fly through these ones. We're going to call win battle like we did before with the hero, except we can access the hero, in this case, the same reference that's stored in hero, this at 428. We can access it through the party. So party, which is, I still have this. Oh, no, that's right. Party.at 596. Grab its character 1 at 482. So we have the same, or 428, we have the same reference as the reference stored in the hero variable. When we call this method, we're going to give that reference to win battle at 428. That's what that character variable parameter is going to store, an XP of 20. So we're doing the same thing as we did when we said win battle of hero mob XP, but we're accessing the heroes, that same character, through the party. Since party.character1 stores the same exact reference as hero, it's going to affect the same memory, the same location in heap space. It's following the same exact reference, same exact object, same exact location in RAM, same exact object in heap space. So since it was the same object, we got the same effect. And this is how we can access character 2. We can't access this any other way. We don't have that reference stored on the stack anywhere, but it is stored in this party. So we can say party.character2 at 227 or 272. I'm getting those backwards. We can go here and actually modify that content, even though we never stored this object, a reference to this object, on the stack directly. We did store it in the heap as part of that party object. So we can still modify it. We can still access it. And then end of the program, wipe all the memory, free it, give it back to the JVM, give it back to the OS. And the program ends. All right, so we will save this next example for Friday, which is fine because Friday is just reserved for examples and going into IntelliJ. So that'll be the end of lecture officially. Yeah, the lab, it'll start at midnight tonight, or technically midnight tomorrow. But as soon as it's Thursday, I'll open the lab and you can access it, and the TAs will have a post on Piazza. Piazza will be the central location for the labs. There will be a Piazza post with all the relevant links, so make sure you're checking that. It'll be pinned. It'll be right at the top when the lab is active, so make sure you're checking that out. The lab starts Thursday. It's all day Thursday, but I'll close, or the TAs rather, will close the lab doc, the form to be able to say that, hey, I'm starting lab right now. We'll close that at 10 p.m. Because if you start right at 10, you have 10 to midnight. You don't have part of Friday. If you start at midnight, you'd have 2 hours of Friday. So it's all of Thursday, but you have to start 2 hours before Thursday ends to be able to fit the lab in. So starting stops at 10 p.m. Then you have 2 hours from your start. So when you fill out the form, that's saying I'm starting, and then it'll give you a link to the lab itself. So you access the lab through that, and then we have your start time recorded, and we'll see, we'll look at your submission times for when you finished it. Yeah, so if you start at 3:30 a.m., you'll have till 5:30 a.m., for example, whenever whenever you started plus 2 hours. Is that how labs were? I don't know how labs were last semester in 115. But if that's how they did it, then it's the same. The dyslexia. Yeah, sorry about that. Look at my numbers backwards. Time to start the game all over again. I mean, not the nitpick, but the time was 2.5 weeks ago to start the game all over again. Look, yeah, thanks, Jared. Cool lecture. This one, I really do like this lecture because it does solidify a lot of the content that we've seen. Introducing classes and objects, I rip through it and just say, here's what they are. Monday kind of reinforces it a little bit, but I have to spend most of the lecture just saying, what is the stack, what is the heap. This is the lecture where I finally have enough stuff out there that I can start gathering it back together and showing you what I've meant for the past week. So I do really like this lecture. It should be where things start to come together and start to make a little more sense. Is there a lecture question on Friday? There's lecture questions every day until late in the semester. For all 5 of the learning objectives, there's 6 lectures and 6 lecture questions. So there'll be a lecture question for every single lecture until the end of learning objective 5. And then those last few weeks of the semester, there's no lecture questions left, which gives you time to finish them. I don't want to give you any learning objective assessment after that anywhere in the last 2 weeks of class. Since you have to complete them all or fail, I want to make sure you have a few weeks to finish them all up. I believe there's 3 weeks at the end of the semester where I'm not throwing any lecture questions at you, if I'm not mistaken. Yeah, these last 3 weeks, weeks 12, 13, and 14, no lecture questions. This is your time to earn your A if you're going for your A. But if you're struggling just to pass, just to complete the learning objectives, these 3 weeks not finals week. These 3 weeks are for you to make sure you have all of your learning objective stuff done, all your makeup interviews, all your lecture questions, everything. Ellipso, see you Friday. But before that, every single lecture has a lecture question, which is quite a bit of work for me as well. A lot of courses you don't see because it's a lot of work just to put together all these assignments, write all these graders. It's less work now that I have all the lecture questions written, but I still want to change quite a few of them, so I still spend a bit of time modifying them. Java 787? What do you expect me? How do you expect me to answer that? I'm only going to watch lecture if there's an activity. I'll just watch it later then. You should just watch them all live. It'll help with your time management. But no, there is no activity today. Do we have a test lab doc for making ourselves get used to labs? No. I used to, but this course is designed with so many makeup opportunities all built in already. There's no one big feature that I want in all my courses, which I have built into this one, is there's no single day of the course that's very stressful for you. You cannot lose whatever grade you're aiming for in a single day. If you're having one bad day, you can still get an A in this course. So if you have a bad day tomorrow and the lab doesn't go well, you're still going to have chances to make that up. Since tomorrow's lab is associated with the homework, you can still complete the homework and do everything you're supposed to do with that and still earn the application objective for that. If you don't finish the lab tomorrow, though, it just factors into your application objective assessment. But if you knock the homework out of the park, you just absolutely crush it, but you just couldn't quite finish the lab within the 2 hours, that can easily be overlooked and you just get credit for the application objective anyway. So I don't see a need to have pre-labs or example labs or anything like that. Sample labs. because you have extra opportunities. Same with interviews, you have opportunities to make those up. Same with lab quizzes for the verifications, for the learning objective verification. All these learning objective verifications, you'll have chances to make those up too. Because if you have one bad day and I'm saying, well, you didn't verify that learning objective, therefore you fail. Like, I'm not like that. That's not how it's happening. So if you get to the lab and it's not what you expected and you can't get it finished, don't sweat it. As long as you give it your best effort, as long as you always put your best foot forward, as long as you're really trying at each step of the way in this course, I'm going to look for ways to make sure you get the credit that you deserve. As long as you eventually can finish stuff. Like if it's clear that you could have finished if you had 3 hours and you really tried for 2 full hours. And when I do get upset, when I do strongly word things in lecture, when you hear me saying that, I'm talking about, I've seen students who submit the lab, who do absolutely terrible on a lab, especially on the lab quizzes, on the verification quizzes, absolutely terrible on them. And I look at the timestamp when they submitted, and it was 15 minutes after they started. They just wrote down some crap, submitted it, and then went and watched TV or played video games, whatever they were doing that was more important than lab. That's what I don't tolerate, and that's where I do start getting upset and stop showing mercy. But if you're working for 2 hours and really giving it your best, I'm going to do what I can to make sure you're going to succeed. Yeah, thanks for reminding me, PJB. Oh, I usually do this. I'll put the chat on stream when I'm behind live chat, just so you can see where I'm at. PJB, yeah, thanks for reminding me, because I still have to finish putting the lab together. So that's my deadline to get it posted. For those of you starting right at 12 a.m. I also have to get it to my TAs in advance so they can get the Piazza post together and all the logistics ready on that front. So when the TAs make the Piazza post, what you should do is post your questions as follow-up conversations on that post so everybody can see the questions. If you have private questions, you can't ask those on a lab. Lab is supposed to be more of a test environment. You should be working on it on your own. The TAs won't necessarily be there for private questions like posting your code in a private post and then saying, what's wrong with this? I'm going to tell the TAs not to answer those. So if they do, they're not doing what they're supposed to. But for questions like, what the hell is this lab even asking for? Just post it as a follow-up on the post that the TAs make so everybody can see the answers. Because maybe I worded something really weird. Maybe something's just not very clear. And everybody can benefit from the answers on those. I'll start at 9:59 p.m. I mean, if you want. I am interested to see when students start. If half the class starts at 9:59. Thanks, Flip Flops. I like this class too. I'm nervous. Yeah, if you're struggling in the course and you're having trouble understanding the concepts and you're a lecture question or two behind, email your first line of defense. Your first action should be to contact the TA who contacted you. All of you should have had a TA who said, hey, my name's TA so-and-so. Let me know if you need help or whatever. That TA is assigned to you for the semester. And each of those TAs only has about 15 students that they're assigned to. So they can spend time on those 15 students and kind of giving you more personalized attention, as opposed to office hours where we have a TA or myself and we have just students coming in and going, and we don't really get to know you or talk to you or anything. By the end of the semester, you should be able to build a rapport with that TA and have personalized meetings with them within reason. To start, I think they're scheduling 15-minute meetings to have personal one-on-one time to help with the material. And then if you need more, they'll make their judgment calls. They may refer you to me. They may refer you to general open office hours if those are the types of questions, whatever it is. But start with that TA, and they'll help you get whatever roadblock is in your way out of your way is their primary goal. So you can keep moving through the course. But use them first. If your next step would be Piazza or office hours. And then after that, hopefully your contact TA can guide you. If nothing's working, they can guide you to whatever the next step might be that'll work well for your situation specifically. Things are starting to make sense. I like that. This is probably my favorite lecture because that is when things start making sense. So far, I've just thrown a bunch of crap at you, and this is where it comes together. I'm really happy when we can get to this lecture. And it's one of the first times where I can slow down a little bit. Because before this, there's so much little content, like explaining all the different types and all the Scala syntax and what's a class and what's an object and what's a state variable. There's just so much I have to throw you. This is one of the first deeper concepts where I can slow down and I really need to explain things a lot slower because it's a bit trickier. Where most of the content before this, there's not much I can say. I throw it out there and you really just have to study on your own and stare at it until it makes sense. 3 weeks, no lecture questions. All right. It's almost 4:42 time, so let me scroll through some of this. All days are bad days. I get this question a lot. If you're behind on a couple lecture questions, which one to focus on? I would at least be aware of the current lecture question, but make sure you're also completing the previous ones. It's up to you where you want to shift your focus. I would try to put your focus on whatever one is making more sense to you. Like if today's lecture kind of made sense, at least try today's lecture question, and then maybe go back to the previous ones after that. But you have to finish them all at some point. Yeah, all days are bad days, especially with this course is tough enough. Doing it fully remote is, it just adds one extra challenge to the situation. Do we only choose one of the two homeworks? Check the syllabus, but yeah, you only have to do one of the two. So choose which one you like a lot more. So I like giving students choices whenever I can, and the homeworks is one big area where I can do that. I used to only have Physics Engine at this part of the course, and I had legitimate complaints from quite a few students who never took high school physics, never took any college physics, and just had no idea what a vector was. So if that describes you and you don't want to learn physics for a computer science class, do rhyming dictionary. Or however you make your decision. I don't care how you make your decision. But if you don't want to learn physics, don't bother with Physics Engine. I recommend Physics Engine, especially if you want to learn, just because I think it's a cooler assignment, but it's whatever you're into. Because Physics Engine, there's a whole game attached to it, and the rest of the game exists except the Physics Engine. So once you build the Physics Engine, you can play the game. And it's a 2D vertical scrolling platformer where you have two characters and you just jump up on platforms, and whoever climbs faster is the winner. So a very simple game, but you can actually see the results of your labor. You can have as many submissions as you want. So the lab tomorrow, the pre-homework labs are graded by submitting 2 Autolab under that homework assignment. I may change the logistics. I may make a separate assignment just for the lab, but it'll be submitting the homework. And you can have as many submissions as you want. Yeah, positive reinforcement. Whoop whoop. Best professor. Yeah, you did spell my name wrong, but you said best professor, so CS professor, so I'll take it. We have extra credit. Yeah. One thing, so I noticed this watching Twitch streamers too. It's certainly the case with me, is you end up answering the same questions over and over and over again. And I don't quite know how to address that. Should I just keep answering the same questions? Like, you can watch the VODs and stuff. Or read the syllabus. It's outlined in the syllabus. I'm going to call this unit testing, I guess. For those of you but you do get credit if you do both, but only up to 2 extras. But check out the syllabus; it outlines it in more detail. So with those of you in 116, 442 is actually about unit testing today. So this is probably one of the better ones to hang out with if you're still here hanging out. But let me cut the stream and go into 442.